Alright guys, I figured I would do this video before I completely lost my voice so you guys could have a lecture for for metallic bonding. So what we're going to be able to do today, we're going to be able to look at two more objectives. You're going to describe and compare properties of ionic, covalent, and metallic bonds. And you're going to have to classify a substance as one of the three bonds based on data. So we're going to be wrapping up all of our types of bonding today and then go from there. So you guys have learned already that we have ionic bonds, which are between metals and nonmetals. We have covalent bonds between nonmetals and nonmetals. But what about if we have bonds between metals and metals, right? And it makes sense that if I have metals bonding with metals, I have a metallic bond, okay? Metallic bonds are between, as I said, metallic elements, so the majority of elements on the periodic table. They are held together extremely strongly, okay? So they're extremely strong. And they are composed of an electron cloud around atoms that create a sea of mobile electrons, all right? So when I have a metallic bond, here's how it works. I have my ions here, okay, my atom, my ion, and then I'm surrounded by this sea of these electrons, okay? So anytime you see the word sea of electrons or mobile electrons, you want to think metallic bonding, okay? Metallic bonds, all right, are good conductors of electricity in all states, whether they're solid, liquid, or gas. They're going to be able to conduct electricity. They're shiny, they're malleable, they're ductile, they have extremely high melting points. Everything that is true for a metal is true for a metallic bond, all right? Some examples we have are down here: sodium, iron, aluminum, gold, silver, and cobalt. And when I am naming a metallic bond, I just name it after the element itself. So it's going to just be a chunk of, like, right, if I have silver here, right, a bunch of silvers together with my sea of electron, I'm just going to call it silver. So there's no special naming for it. Okay. A type of metal bond or metallic bond is an alloy. Okay. And an alloy is a metal made up of combining two or more metallic elements, okay, that are made up of only metals. Meaning, okay, if you see here, oh crap, I can't zoom it in, okay, each of these red circles represent one type of metallic ion, right? So say I'm talking about copper, okay? Here I would have all copper, so I'm pure copper. Over here, I'm going to have a type of alloy, right? I have copper and maybe I have some tin included, right? So now I have a type of alloy here, right? Same thing here. I have another metal here, right? So these are different types of alloys depending on how it's set up in terms of my element that is there, okay? Some properties of alloys are similar to just metallic bonds, right? So they're going to be solids at room temperatures. They're still going to have high melting points. They're still going to be good conductors of electricity. The only difference is their names are not found on the periodic table, okay? So for example, we have steel. We've talked about steel in class before. We have brass, we have bronze, we have pewter, right? So these are a compound of metals, right? And so if I look at bronze, right, if you think about a bronze medal from like the Olympics, right, Tokyo 2020, right, our athletes that receive a bronze medal are actually getting a mixture of copper and tin, right? If we have someone who likes to play a brass instrument like the trumpet, right, it's actually a mix of zinc, tin, and copper, okay? So those are what alloys are. So what we're going to do now is we're going to tie the three types of elemental bonds together. All right, so metallic bond is super easy. It doesn't take too long. There's nothing super special about naming or figuring out the chemical formulas. So we flew right through that. So now what we're going to do is we're going to tie all of it together. Okay, so in your slides you have, in your notes, you can tell I'm losing it, guys. Welcome to being sick. As we go through these slides in your notes, you have a table. In each table, and in your table, each thing has a heading and then the type of bond. So we're going to be filling in this information here, right? So for the types of elements, that just means what are each bond made up of. So I have ionic bonds, right? We know are made up of metal cations, non-metal anions. Covalent bonds are all nonmetals. Metallic bonds are all metals, okay? Right, the only one that's a mixture of two types of elements is my ionic bond, and that's really how we tell that it's ionic, okay? In terms of valence electrons and how they move, right, we know ionic bonds are completely transferred. Covalent bonds have electrons being shared. And now we know metallic bonds are a sea of electrons, right? So anytime we said sea or we had mobile, okay, electrons, we're talking about metallic bonding, okay? Products, what does it create, okay? Ionic bonds, we know, create a compound. Sorry, guys. Okay, and that compound can be shown as a crystalline solid or a salt, okay? Covalent bonds create molecules, and they're either molecular solids or network solids, depending on how their elements are arranged. And then metallic bonds are either a metal or an alloy, okay? So this is how we can kind of look at those solids here, right? Metallic solids, right, have just a network of all metals coming together. Sometimes it's one pure type, sometimes it's an alloy. Ionic solids are held together here, right? Say this is sodium chloride, right? Sodium chloride, sodium chloride, sodium chloride, right? Sodium chloride. So they're all held together by opposites attracting one another, and this is what we call a crystalline solid, okay? Next we have, right, our covalent bonds. We said one's a molecular solid, right? H2O, CH4, okay? The other type that we haven't talked too much about, but you do have to be able to recognize, is what's called a network solid, and these are elements, okay? These are covalent bonds in which atoms are held together, but in a very distinct pattern. So we see this a lot with diamonds, right? Graphite, different types of elements held together by covalent bonds in a very specific structure. Okay, so these are our four types. Our states of matter at room temperature. Okay, ionic bonds tend to be solid but brittle. Covalent bonds are mostly gas or liquid, and our metallic bonds tend to be solid except for hydrogen, except for mercury and bromine that we know are liquid at room temperature. Okay, I don't know why I just said bromine. Mercury is the only exception. Mercury is a liquid at room temperature. All the other metallic bonds are solids. Okay. Melting and boiling points. Sorry, guys. All right, we have melting and boiling points. Okay. Biggest thing here is ionic bonds have a high melting and boiling point, as do metallic bonds. Covalent bonds have a low boiling and melting point. Okay. Conductor of electricity. Okay. Ionic bonds are good conductors, but only when dissolved. Okay. Meaning if I had salt, right, NaCl, if I just had a lump of salt, right, like what you put on your food, if it's a solid, it's going to be a poor conductor. But if I dissolve salt in water, it's going to be a good conductor of electricity. And that is what we saw. Sorry, guys, I'm losing my voice as I go through this. Thank God I have 2 more slides left. Okay. Right, we saw that ionic bond conductor of electricity when we looked at that video. Sorry, I was drinking water there. When we looked at that video at the very, very, very beginning of ionic bonding, right? And we saw that it was able to light the light bulb up, but only when it was dissolved in water. Okay. Covalent bonds really don't conduct electricity, right? So all covalent bonds tend to be poor conductors, and metallic bonds tend to be very good conductors in any state, so solid, liquid, or gas. Okay. And it's super easy to kind of think about these properties because if you think about what they're created of, right? Metallic bonds are created of metal. So both, or like most metals, are good conductors, right? Ionic bonds are metals and nonmetals, so we kind of have that mixture. So it makes sense that they're really only good when I'm dissolved and I break apart into my ions, right? Same thing with melting points, boiling points, okay? States at room temperature, all right? So keep that in mind, right? We can tie it all together by thinking about what our bonds are created of, all right? So what I want you guys to do is you can pause the video and I want you to answer these summary questions, please and thank you. You guys should know the drill, right? I want you to be able to tell me what are the differences between and similarities between ionic, covalent, and metallic bonds. And I want you to be able to classify a substance as ionic, covalent, and metallic, and how can I do that based on data? And we're going to be doing that in this practice, all right? All right, once you have finished your summary, which hopefully you all have because you know that you pause the video, write your summary, and come back to the video, we're going to do some stuff, okay? First thing we're going to do is we're going to do a card sort. I'm going to give you properties of metallic, ionic, and covalent bonds. And your job as a group is you are going to be uploading that to Google Classroom for a participation / like binder check grade, so you have to do it. I will have further instructions on the board for you once you finish the video. Once you do that, you're going to have a practice of naming and writing the formulas of ionic, covalent, metallic bonds, and then you guys can take your Mastery Connect quiz. All right, so that is it for today. Hopefully the next video my voice doesn't sound so bad, and we are done with this lecture.